Art of Fighting Against Malware Part 2. In this episode, we will demonstrate the different challenges security operations centers face when they are willing to establish malware reverse engineering capabilities on their own, and malware reverse engineering as a service, as a possible solution to overcome these challenges. Before we jump into today's topic, let's get back to the closure of our previous episode, and see the main use cases when human-aided malware reverse engineering must be performed, and its place in modern security operations, so you can understand the root cause of the main challenges of establishing in-house malware reverse engineering capabilities. There are certain scenarios during the daily operations of a security operations center when automated malware analysis tools have fulfilled their tasks and questions regarding a suspicious code are still open. The ambiguity during incident management can be caused by a potentially inaccurate verdict or the need to reveal why a given decision was made by an automated tool. The new generation of malware uses highly evasive techniques to bypass automated malware analysis tools, therefore, verification of the verdict might be necessary. Legitimate programs might act suspiciously, so understanding the reasons that led to the decision can be essential before overriding it. Investigation of malware incidents does not stop at blocking malicious code. Understanding what the code does enables an effective response to the incident, including identifying which assets are impacted and how. I comment in advance and will elaborate on it later. There is relevance in applying the available malware analysis tools within a SOC. However, there will be always situations when human-aided reverse engineering needs to be involved. With regards to the question of how malware reverse engineering fits into the SOC, let me refer back to the well-known representation of the people, process, and technology layers of the security operations centers. The primary goal of malware reverse engineering is to support incident detection and incident response, so it will provide benefits primarily for the detection and response processes. Certainly, it has connections with threat intelligence and vulnerability management processes as well. The way how our service is designed is to focus on the support of the response part. During the response process, you must complete containment, analysis, eradication, and remediation activities. Malware reverse engineering complements the existing automated or manual malware analysis processes. The report that we create is primarily built to support the proper containment of the incident as well as eradication and remediation steps. Now that we saw what the background problem is, let's continue with how it should be solved. The answer is quite obvious: we need to build the malware reverse engineering capability in the SOC. When SOC management decides to do that, it will bring up even more challenges. I think I do not need to mention the difficulties caused by the shortage of talented and skilled cybersecurity professionals. If we consider a niche skill set like malware reverse engineering, then the gap is even higher. It's very hard to find truly skilled professionals for malware reverse engineering even on a global scale. Let's assume that we found the right professionals. Recruiting them is challenging too. It's very expensive to keep them on payroll, and going further, assuming that we could hire them, the next challenge is to retain them. This links back to the initial fact that only a very limited amount of truly skilled professionals is available in this field even on a global scale, so the competition who tries to capture their knowledge is strong. The difficulty of building this capability in-house suggests that it would be most probably more beneficial to gain it in the as-a-service model. Ideally, malware reverse engineering as a service should be available at high capacity, in an on-demand manner, even for ad hoc cases. When we looked around the market, we found that not so many offerings like this are available having these characteristics. We have access to the required skill set, therefore it became obvious to form this service and offer it primarily to counterpart security operations centers and incident response teams. Let's quickly go through how we operate the service to enable the desired characteristics, such as scalability and on-demand accessibility. To ensure high capacity, a purpose-built malware analysis lab was designed and implemented that incorporates in-house developed hardware and software components. The lab is deployed on our premises, so the samples analyzed are not shared with additional third parties. The malware sample can be shared via multiple methods depending on the customer's preference. The incoming samples land in the so-called malware triaging pipeline. The malware triaging pipeline performs several pre-processing types of activities to ensure optimal utilization of the resources of our malware reverse engineers. The outcome of the analysis is a customizable report which is by default optimized for incident management. It's important to emphasize that the report is intended to help with practical incident response. To get clear information on whether the code is malicious, what it does, how it can be recognized, and how should it be remediated. Therefore, it enables speedy response actions such as containment, remediation, or even hunting. It's not a primary goal to provide a full academic or research type of analysis for the samples. Of course, we are capable to support digital forensics, but that is part of a separate service umbrella. Due to the nature of the service design, it can be easily integrated with the existing Security Operations Center technologies and processes. Therefore, even the proof of value process is simple. We usually suggest selecting a sample and sharing it with us through any of the preferred methods. Then the sample goes through the service and the same level of the report will be generated as it would be done in the case of the commercial service. It will be sent back to the partner who can evaluate the result. We usually propose to select a sample for the proof of value process that is well known to the partner, so in the end, they can compare what they get to the expectations. Or if they have a sample that caused some trouble and still don't know how to deal with that, it's another great candidate for the proof of value process. Let's talk briefly about how the service or the malware reverse engineering process itself should be used within a security operations center. Malware reverse engineering is intended to complete the existing capabilities of malware analysis, so it means that the existing technology or processes should not be replaced with it. The malware reverse engineering is intended to rather complement them. The existing sandboxes, EDR systems, the local processes for static and dynamic analysis should be kept. This new service or process comes into the picture when you let the sample go through all the technical elements and you completed all your processes, and you still have questions or doubts what the malware sample does or what you should do to get the consequences remediated. The primary purpose of the service is to support and complement tactical malware analysis processes, also, to help verdict validation when there is doubt on the verdict which was provided by the cybersecurity tool that you use, or to support in any other cases when you need a deeper understanding of what a potentially malicious code does to support your internal processes. To conclude the train of thought, let's summarize a few takeaways. First of all, definitely there is a need to complement the existing malware analysis capabilities in a security operations center with malware reverse engineering because there are certain scenarios when someone with the skill set of interpreting the potentially malicious code on an assembly level is required. Establishing this capability in-house is very challenging due to several reasons. Even if you have the capability in-house, you might run out of resources, so extending the existing capability with on-demand service will help increase the maturity of a SOC. And once again, malware reverse engineering does not replace but rather completes the traditional security operations center processes. It should be used when the analysis was completed, meaning that the sample went through all the existing technology elements and all the internal processes, but there are still uncertainty and questions about a potentially malicious sample. Thank you for joining us for the second episode of The Art of Fighting Against Malware. If you seek professional support in handling malware incidents on the highest level, or want to learn more about how to fight efficiently against malware, visit our website or follow us via LinkedIn.